Welcome back to my YouTube channel. Today I'm talking about the Poisson function in R. The Poisson function is a part of a group of R functions that start with R and have the name of the distribution either in full or shortened to represent a statistical distribution. This generates random numbers from the Poisson distribution, and I'm going to go ahead and get started. I'm going to use R voice to generate 10 million, which would be the first argument. That's 1 million. I looked at the 10 and said 10 million. So 10 to the 6 is 1 million, and I'm going to set the parameter of the distribution equal to 5. The parameter of the Poisson distribution is lambda, which is the rate constant, or the mean, or the variance, however you want to think about it. So we can check our answer here. The mean is equal to 5. Of course, we're randomly generating from the distribution, so it's never going to equal exactly 5. And then the variance also equals 5. One handy thing you can do with all of these distributions is you can look at the proportion in the tails without having to use the P and Q norm. Although, if you do it this way, by a simulation approach, you're never going to get an exact answer. And if you need an exact answer, you're going to have to figure out what tail you're in and everything associated with P, Q, and D norm. But if you just need a quick calculation that's easy to think about, just take your work, you can simulate. So for this, I'm going to make a counter variable that starts at 0, and make a for loop for the distribution. So I'm going to pick I in 1 to the length of x, which would be 1 to 1 million. And I want to make an if statement. So if x of I equals no, I actually want to do less than or equal to 3. I want to say I want the proportion less than x, less than 3. Okay? The proportion of x less than 3. Okay? So every time I find one of those, I want my counter to go up 1. Okay, so we have that counter, and now if I want the proportion, I just have to divide that counter by 10 to the 6, and I end up with 0.2655 or less than or equal to 3. And if we use hit, we'll see that looked about right. I use abline v equals to 3. That's not the most helpful, is it? Let's try to zoom in. V equals to 3. And I'm going to do a little bit better here and call that red. Okay, so we're saying about 0.26 or 0.27 of the distribution is equal to or less than 3. Okay? That's all I have for the video. Thank you for watching.